Here is the second part of 5.5 but 5.6. So first off, I want to talk about what a factorial is. And this is just the stuff right out of your book. A factorial is just any number counting down. So 4 factorial is 4 times 3 times 2 times 1. That's what this means. The first number times the first number minus 1. And then you would do times the first number minus 2, etc. until you got down to 1. 0 factorial is 1, and 1 factorial is 1. I'm going to leave the rest of this and come back and use examples to help you understand this, and then you can look at it later. So here's my first example. There are 4 teams in the women's gymnastics final: Russia, China, USA, and Japan. How many different ways can the gold, silver, and bronze medals be awarded? List all the possibilities. So think about it. We have 4 teams to choose from and 3 medals. If we were in class, I would have made you do this by yourself so you could try. But think, well, Russia could get gold, China could get silver, USA bronze, or Russia could get gold, China bronze, USA silver, and you could do all the combinations. If you did that, it would take you a while, but you could probably figure out there are 24 different combinations. This is called a permutation. It is a permutation, and the formula down here to find it is n factorial all over n minus r factorial, and it is n distinct objects where you pick r of them, and order matters. And what it means by order matters is this one had Russia, China, and the USA, but Russia came first, China second, and USA third. That is different than Russia first, China third, USA second, or gold, bronze, and silver. Even though they are the same people or the same countries, they are different outcomes. So order matters, okay? And you may have seen this before. So it's called a permutation. We do it by doing 4p3 or total and pick 3 of them to put in order. Okay, if you did the formula, 4 factorial, that'd be 4 times 3 times 2 times 1, divided by 4 minus 3, or divided by 1, and you would get 24 ways. Notice this is very much like the multiplication counting principle we did before. Okay, and when you hear of a combination lock, maybe you would put on your locker, that is actually a permutation lock because your combination of 1, 2, 3 is different than a combination of 2, 1, 3. The next one would be this story problem. Papa John's pizza only has the following toppings to choose from: pepperoni, sausage, mushroom, and green peppers. You are getting a 3-topping pizza. How many different pizzas could you get? So again, you could list all the possibilities. This is just some of them. Notice I have P for pepperoni and so on. But if you did that, you would come to realize that some of the combinations would be the same pizza. Because if you got a pepperoni, sausage, mushroom pizza, that would be the same as a sausage, mushroom, pepperoni pizza, unless you're super, 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 super picky, and then you think they're different pizzas, but really they're the same pizzas. You just ordered the toppings in a different way. So this is called a combination, and it's the same idea, okay, except for it's n objects, and you choose r of them, but order doesn't matter. So it doesn't matter in which order you pick them. If you pick pepperoni, sausage, and mushroom, you're going to end up with the same pizza as if you picked sausage, pepperoni, and then mushroom. And you could use the formula for that. So that's 4 toppings, pick 3 of them to be on there. And what this extra 3 factorial does is it divides out all of the duplicates that we have. So if you did 4 factorial, that's 4 times 3 times 2 times 1. 4 minus 3 factorial right there, that's your 1. And I apologize, there's a little bit of a lag. And then this 3 factorial, which is the 3 times 2 times 1, that is dividing out all the duplicates. So really there are only 4 possible pizzas that you could make. Now you don't actually have to do the formulas. You can use your calculator. And before I talk to you about that, I also want to show you 4C3 can be written as this: 4 choose 3, which you may have seen last year when you were doing binomial expansions and we used Pascal's triangle. So you may have seen some of that last year, like 4 choose 1, 4 choose 2. But anyway, the way to do it in your calculator, and I don't have my calculator app on this computer, but you would go to, let's say you wanted to do 4 choose 3, you would do 4 and then you would go to math, and I think it's under PRB again, but you have to look, and you'll see like NCR. So you'll pick that, and then it'll go back to your main screen and do a 3, and it'll turn into 4C3, hit enter, and you will get 4 ways. We have the same thing for permutations. So that back here is what they're talking about for permutations. This is what your book says to look at, and combinations, okay? This last little bit right here are some examples. So I'd like you to pause and look at these examples and see if you can order them or decide like is this one a permutation or a combination? And you will notice that 2, 3, 6, and 12 are a little different. See if you can figure it out. Okay, now that you've checked, hopefully you would have gotten this. And my guess is you probably called these guys, combinations, but they are permutations. They are just a special type of permutation. So I'll talk about those in a second. Let's look at number 1 though. 7 shoppers in a line at a checkout counter would be a permutation because it matters. You want to be the first in line, not in the last. So you would do 7P7 in your calculator, or you could use the formula, but you would get 5,040. If you were to look at number 5, okay, we need a group of 7. We have a group of 7 students that we're going to pick out of 36. We don't care, okay, in which order we pick those 7 students, they make the group. So that is a combination, and there's that many ways you could pick different groups. The other ones are actually called distinct permutations. And we are ordering letters, but the problem is for example, in the word intercept, some letters show up twice. So E and E, we don't want to double count those, right? Because it doesn't really matter which E you put first. So that is called a distinct permutation or distinguishable permutation because you can't distinguish between the 2 E's, and this is how you do it. You put the total number on the top and then divide by factorials for each thing you have. So let me show you here. Okay, we have 9 tiles. Okay, 4 plus 2 plus 3, so that's your total. But 4 of them were duplicated, so we're going to divide by 4 because 4 were blue, 2 were red, and 3 were black. Now, if some of those were 1, so maybe this was 10 tiles, and you also had 1 green tile, you could put 1 factorial down here as well, and that's what your formula tells you to do. But you don't need to divide by 1, that doesn't change anything. So you only actually have to put the duplicates in the denominator, which is what I was saying right here. You only need to do the duplicates. Hopefully this is a review from Secondary 3. Lastly, I have these different problems right out of your book, and I'm going to let you read those and see if they help, if you can figure it out. I'll do this first one, but I'll let you read the last 2 and then contact me with questions. Here is a summary of everything that we just discussed. And I'll go back and do those problems in a sec, but I wanted to show you the summary. Here's how to use it on your calculator. And then 5.6 puts it all together. So I'll let you look at that as well. Okay, but let's go back and just do this very last example. A DNA sequence consists of a series of letters representing a DNA strand that spells out a genetic code. There are 4 possible letters, A, C, G, and T, each representing a specific nucleotide base. How many distinguishable sequences can be formed using the 2 A's, 2 C's, 3 G's, and 1 T? So they are showing you where this funky formula right here comes from. Okay, and in class on A day, we actually went through exactly how it happens, but I'm just going to let you shortcut it. So if you want to see where the formula is derived from, follow all of this. Okay, but otherwise, we have 8 possible nucleotides, but we have repeats because we have 2 A's, so we divide out the A's, 2 C's, 3 G's, and 1 T, which you didn't even need to put in, and you don't need the 0 as well. This part would be if you just did a bunch of combinations, because basically, I guess I should talk about it just quickly. For the first, if you have 8 spots, you have to pick 2 of them to put in an A. So maybe you put those 2. But then so we use the multiplication rule, and now you have 6 slots left. You need to put 2 of them for your C's. And so you just multiply those all together. If you use the different combination formula, stuff cancels out and you get the shortcut formula. Okay, and then what you can do is if you get one of these totals, I'm going to not go over the last example, but what they would do is you'd get one of these total and then you divide it by the total possible number of ways in general, something like that, to get a probability. And that is what they're going to talk about down here. So good luck on the homework, and please email me if you have questions.